I'm Teacher Neth, and welcome back to Statistics and Probability class. Now that you have knowledge of the z-score and the normal curve, in this lesson, we will focus on the area under that normal curve. The area under the normal curve is associated with probability, proportion, or percentage. The table of areas under the normal curve is also known as the z-table. To locate the area corresponding to a z-value, find the area between z equals 0 and the given z-value using the z-table. To find the area under the normal curve given a z-value, here are the steps. First, express the given z-value as a 3-digit form. Second, by referring to the z-table, locate the first 2 digits on the first column. Third, locate the last digit by referring to the first row of the table. Fourth, the required area or probability is located at the intersection of the row and column. You'll understand how it works in the following examples.
Example 1. Find the area between z equals 0 and z equals 2. That means, in a normal curve, we need to find the area of this shaded region. That is, from z equals 0 up to z equals 2. In order for us to find the area of this shaded region, we need to use a z-table. And before I show you the z-table, take note that the z-table gives us the corresponding area from this point, from z equals 0 up to another z value. So this is the z-table. In using the z-table, you need to express the given z, which in this case is z equals 2, in terms of a 3-digit number. So that is 2.00. In the z-table, the first 2 digits is located in the first column. So 2.0 is here. And then the last digit will be from this row, the first row. So since the last digit is 0, then you will choose this number. And where do these 2 encircled numbers meet? They meet at this number. Therefore, the area of z equals 2 is 0.4772. So going back to the problem, wherein we are asked to find the area between z equals 0 and z equals 2, or this shaded region, we have known from the table, from the z-table, that the area is 0.4772. Example 2. Find the area between z equals -1 and z equals 1.5. Under the normal curve, we are asked to find the area of this shaded region. That is from z equals -1 up to the point where z is equal to 1.5. Take note that the z-table gives us the area from 0 to a certain number, to its right. That means if the total area of the region under the curve is 1.0 or 1, then half of it is 0.5. This is 0.5 and the other half is 0.5. So if we would like to find the area from -1 to 1.5 under the normal curve, the strategy will be to get the sum of the areas of these two. Because there is no direct area that the z-table will give us from a negative number to a positive 1. It only gives us the area from 0 to another number, positive number actually. So for us to find the area of this region, or of this region first, then it's the same as the area from 0 to positive 1 because they have the same interval. -1 to 0 and 0 to 1 are equal. or have the same interval. So if you would like to get the area from -1 to 0, that is the same as from 0 to 1 in the Z table. So this is the Z table. First, we need to find the area from -1 to 0. Because again, the Z table gives us the area from 0 to a number to its right. So we cannot find the area from -1 to 1.5 directly, like what we've explained earlier. So let's find the area from -1 to 0 from this table. And that is equivalent to the area from 0 to +1. So +1 can be expressed in terms of 3 digits, and that is 1.00. This is also equal to 1. So the first 2 digits will come again from the column that is located here. And the third digit, which is again 0, this has a point here, is located here in the first row. Where is this 0? It's here. The third digit is 0, or the hundredths digit is 0. And these two encircled numbers meet at this point. So that's 0.3413. The area when Z is equal to 1.0, that's from 0 to 1, is 0.3413, which is of course the same as the area from -1 to 0. So going back to the normal curve, we've seen that the area from -1 to 0 is 0.3413. Now, it's time for us to solve for the area of this region, that is from 0 to 1.5. So to continue, we are now going to solve for the area from 0 to 1.5. Since the Z table gives the area from 0 to a number to its right, then solving for the area of 0 to 1.5 is very easy. We will just locate 1.5 or 1.50 from the table, because this table gives us the area of a 3-digit number. The first 2 digit, which is 1.5, let's locate that in the column, 1.5 here. I'll encircle it. Then the third digit, or the hundredths place, is 0. Let's look from the row. The hundredths place must be 0. So this is that number. The third digit, or the hundredths place, is 0. And if we try to locate the cell where they will meet, the area when Z is equal to 1.5 is 0.4332. So let's go back to the normal curve. So from the Z table, we've known that the area from 0 to 1.5 is 0.4332. And in order for us to determine the area of the whole shaded region, then we need to find the sum of these two. That is 0.3413 plus 0.4332, which is equal to 0.7745. Example 3. Find the area below Z is equal to -1.42. Under the normal curve, the area below Z equals -1.42 is this shaded region. That is because this point is equal to -1.42. That's between -1 and -2. Now, before I continue, before we start getting the area of this region, I would like first to catch your attention to this term below. Whenever you see this term, if you're talking about the normal curve, that also means the same as the following terms: to the left of, or less than, or at most. So this problem can be rephrased as find the area to the left of Z equals -1.42. the region will still be this shaded area, or it can be rephrased as find the area less than z equals a certain number. So that would also mean this area to the left of, or less than, or at most. So find the area where z is equal to negative 1.42 at most. So at most meaning all the numbers to its left and exactly equal to it. So all the numbers to its left again, or below, or less than. So these four terms mean the same thing. So now let us continue finding the area of this region, which is below z is equal to negative 1.42. Recall that this curve is divided into two. In the z table, or the z table gives us the area only of this region, that is from 0 to a certain positive number. Now, if we are going to solve for this area, which is to the far left of 0, to the left, to its left, then the strategy will be to solve first for the area of this region, the unshaded one, from 0 up to negative 1.42. Now, for us to do that, because the z-table does not give us an area from 0 to a certain number to its left, then we need to find its equivalent to the right. That is from 0 to 1.42. So let us solve for that first. So again, what we are going to find is the area of the region from 0 to 1.42 first, positive 1.42. So let us first disregard this given. So 0 to 1.42. Where is 1.4 in the first column? 1.4 is here. And then in the row, from this row, we are going to find the hundredths place. So that is 0.002. And that is here. And then locate the cell where these two meet, the row and the column. They meet at this number, 0.4222. That is the area from 0 to 1.42. Now, since the area from 0 to 1.42 is 0.4222, then that means the area from this number, from negative 1.42 to 0, is also 0.4222 because they are only the same. They have the same intervals. And this is symmetric to the right. Next, since we are asked to solve for the area of the shaded region and not this part, and since the area of this is 0.5, because again they are symmetric, each is 0.5, then the area of this region is 0.5, the area of this half, minus the area of this part, the white part, 0.4222. And that is equal to 0.0778. That is the area of the shaded region. Example 4. Find the area between z is equal to 1.37 and z is equal to 2.05. If you locate that area in the under the normal curve, that is the shaded region. Since this is 1.37 and this is 2.05, then we are asked to solve for the area of this shaded region. Area between them, that will be the z values. So this is that. What will be our strategy? So our strategy is to solve first for the area from 0 to 2, and then the area from 0 to 1.37. And then we'll get their difference. That will be the area of the shaded region. The area of this region cannot be directly known from the table. Again, because the table, the z table, gives us only the area from 0 to a number, to a z value to its right. So given that, then we will solve first for the area from 0 to 2.05. then minus the area from 0 to 1.37. Okay, so from the Z table, you may opt to get first the area of 1.37, or you may get first the area of 2.05. So let me get first the area of z equals 2.05. Since it is expressed already in terms of 3 digits, then I'll first consider 2.0. From the column, 2.0 is here. So let's encircle it. Then, like what we've said, the hundredths place will come from the row. 0.05 is located here. And then, the two encircled numbers will meet at this cell. That means the area from 0 to 2.05 is 0.4798. So, from the Z table, we've known that the area from 0 to 2.05 is 0.4798. And this time, we'll find the area of the region from 0 to 1.37. 1.3 first. From the column, 1.3 is located here. And then, the hundredths place, which is 7, 0.007, is this number. This column, and then this row, they'll meet at this cell. That means, the area of 0 to 1.37, Z values, is 0.4147. Okay, from the table, we've known that the area of this portion, 0 to 1.37, is 0.4147. Now that we've known the area of this region, and then this region as well, then to know the area of the shaded region, we'll only use subtraction. 0.4798 minus 0.4147 will give us the area of the shaded region. That is 0.0651. Example 5. Find the area to the right of z equals 0.89. When we try to locate it under the normal curve, we know that this is 0.989. That area will be this shaded region. So we would like to know the area of this shaded region. But before we proceed, let me first catch your attention to this term. To the right of. So that literally means the area or the portion to the right of the given number. So to the right of 0.89. But sometimes the given terms are this, above, or greater than, or at least. But take note that these four mean the same thing. Or there might be another term which will mean the same as these four. So this can also be rephrased as find the area above z equals 0.89. The areas above it or the numbers above it are those to its right. And then it can also be termed as find the area greater than z is equal to 0.89. We know that the numbers greater than it are those to its right. Or it can also be termed as at least. Find the area where z is equal to 0.89 at least, or where z is at least 0.89. So that means at least, so it can be greater than 0.89, from 0.89 up to the numbers to its right. Okay, let's proceed. So that means if we are going to find the area of this region, we cannot find that directly from the z table because the z table gives us the area from 0 to a certain number to its right. So the strategy that we will use is to solve for the area of this region first, the unshaded region, from 0 up to 0.89. And then since the area of this half of the normal curve is 0.5, then we will just be subtracting the area of this part from 0.5 to get the area of the shaded region. Again, we would like to know the area of the region under the normal curve from 0 to 0.89. Since the given number is expressed in terms of 3 digits already, then we may consider this number. Again, the first 2 digits will come from the column. So this is 0.8. And the last digit, which is 9, 0.09, is here in the row. And this column and this row will meet at this cell or at this value. This is the area from 0 to 0.89. That's 0.3133. So from the table, we've known that the area of this unshaded region is 0.3133. But we are after the area of this shaded region. Like what we've mentioned, our strategy will be to subtract this area from 0.5 because the area of half of this normal curve is 0.5. So that is 0.5 minus 0.3133, and that is equal to 0.1867. The area to the right of Z equals 0.89.
It's challenging and fun to get areas under the normal curve, right? The key is just to sketch a normal curve and locate and shade the area being asked. From there, you'll be able to strategize a solution with the aid of your Z table. Until next time.